Hey everyone, welcome back to the channel. In this masterclass, we are doing a complete, from the ground up deep dive into Spring Data JPA and the N+1 problem. By the end of this video, you'll understand it well enough to use it confidently in production and explain it clearly in an interview. If that sounds good, make sure you are subscribed and let's get started. The N+1 problem is one of the most common and costly performance bugs in Java applications. We are going to tear it apart completely, from how Spring Data JPA works under the hood, all the way through every technique available to eliminate it. Real code, real SQL, real trade-offs. The scenario is real: 1 endpoint, 4-second response time, 847 database queries. The APM dashboard shows the spike, but the actual cause is buried in code that looks completely reasonable. Hibernate's default behavior silently generates a query for every associated entity it needs to load, and that number scales directly with how many rows come back from the first query. The N+1 pattern always has the same shape. One query fetches a collection, say, all orders. Then, for every order in that collection, Hibernate fires a separate query to load the associated entity, say, the customer. If you loaded 100 orders, you get 101 queries. Load 846 orders, and you get 847. The first query is the one, every follow-up is one of them. Quick pause: if this is useful so far, drop a like, subscribe for a new masterclass every week, and share it with a teammate who would find it useful. Now, back to it. Spring Data JPA is a layer of abstraction. The specification is JPA, Java Persistence API. The implementation doing the real work is Hibernate. When you call findAll on a repository, Spring Data translates that into a JPQL query, Hibernate compiles it to SQL, executes it, and then maps the result set back to your entity objects. Every fetch decision, whether to issue one query or 100, is made by Hibernate based on how your entities are annotated. This is the starting point to entities with a many-to-one relationship. An order belongs to a customer. The fetch type is lazy, which is the recommended default, and the JPA specification default for to-one relationships in Hibernate. Lazy means Hibernate will not load the customer when it loads the order, it will wait until your code actually accesses that field. That delay is exactly what creates the N+1 problem. This is the offending code, and notice how innocent it looks. findAll executes one SQL query and returns a list of order objects. Then the stream iterates over them and calls getCustomer.getName on each one. Because the customer association is lazy, Hibernate has not loaded it yet. The moment getName is called, Hibernate fires a new select to the database once per order. 100 orders means 100 extra queries, all happening invisibly inside what looks like a simple map operation. A common instinct is to switch fetch type to eager and call it solved. That is the wrong lesson. Eager means every time you load an order, even when you only need the total amount and never touch the customer, Hibernate joins in the customer anyway. With deeper object graphs, eager cascades into a tree of joins that loads far more data than you need. Lazy is the correct default. The real fix is telling Hibernate exactly what to load and exactly when, through explicit fetch strategies, which is what the rest of this masterclass is about. Developers constantly reach for annotations like band-aids without understanding what is actually producing the problem. We fix that now by mapping every layer in the stack, from the raw JDBC driver all the way up to Spring Data JPA, so you can trace exactly where a query originates and why. Each layer has a single, well-defined responsibility. JDBC speaks raw SQL through prepared statement and result set. It knows nothing about Java objects. Hibernate sits above it as the ORM, translating your author class to the author table and generating SQL. JPA is the specification that defines the contract, the interfaces and annotations in Jakarta.pe systems, and Hibernate is the engine that honors that contract at runtime. Spring Data JPA sits above all of them, eliminating boilerplate through repository interfaces and derived query methods. This distinction trips up experienced developers, not just beginners. JPA defines what must happen, Hibernate defines how it actually happens. When lazy loading misbehaves or N+1 queries appear, the root cause is almost always in Hibernate's behavior, not in the JPA annotations you wrote. Knowing which layer owns the problem tells you exactly where to look. Spring Data JPA is the layer most of us write against every day, which makes it easy to forget how much is happening beneath it. When you call find by last name and first name, Spring Data parses that method name at application startup, produces the equivalent JPQL, and hands it down to Hibernate, which generates SQL and fires it through JDBC. A single method call cascades through 6 distinct layers. The persistence context is the most important concept in JPA and the one most tutorials skip over. Every entity manager, and in a Spring application you typically get one per transaction, maintains exactly one persistence context. Understanding it is non-negotiable for diagnosing N+1 problems, lazy initialization exceptions, and unexpected SQL. When Hibernate loads an author with ID 1, it registers that object in the persistence context. If the same transaction requests author ID 1 again, Hibernate returns the same Java object reference without touching the database. This is the identity map, also called the first-level cache. This provides deduplication within a transaction, but it does not prevent extra SQL statements from firing in the first place, which is exactly why N+1 still happens. These 4 states appear in virtually every JPA interview and, more importantly, in virtually every real bug report. A managed entity is silently watched by Hibernate. Any field you change will be written to the database when the transaction commits, even without an explicit save call. A detached entity looks like a normal Java object but will throw a lazy initialization exception the moment you try to traverse an uninitialized collection, because there is no longer an active persistence context to execute the query. This sequence walks through all 4 states with a single author entity. Notice that once an entity is managed, you never call an update method. Hibernate's dirty checking mechanism detects the field change and generates the update statement automatically at commit time. The detached case at the end is the source of one of the most common JPA exceptions in production, accessing a lazy collection after the persistence context has already closed. We are now at the mechanical core of one of the most common Spring Data JPA performance issues. Understanding proxies at this level means you will never be surprised by an N+1 problem again. You will see it coming before you write the code. When Hibernate loads an author entity and sees a lazily fetched books collection, it hands you back a byte-degenerated subclass of your entity, not the real thing. That proxy knows the entity's ID and nothing else. No SQL has been fired for the association yet. Every lazily loaded entity is secretly one of these generated subclass. The proxy overrides every getter. The first time any getter that needs real data is called, the proxy intercepts it, fires a select against the database, populates itself, and only then delegates to the real field. The ID is always safe, everything else triggers initialization. This is the N+1 pattern in full. One query loads the author list, that is the one. Then iterating over that list and calling getBooks on each author triggers one additional select per author, those are the N. With 1,000 authors, you have 1,001 database round trips where one would have been enough. This is the critical mindset shift. Hibernate is not broken. It is doing precisely what you asked: defer the load until you need it, then fetch it. The architectural mistake is iterating a lazily loaded collection inside a loop without giving Hibernate the opportunity to batch or join. We will fix that, but we have to own the cause first. The second-level cache is often raised as an N+1 mitigation, and it can reduce the observable impact when the cache is warped. But it does not eliminate the N+1 pattern, it masks it. Under fresh load, after a restart, or with frequently changing data, every one of those N queries still travels to the database. We will cover real structural solutions next. We are going to construct a crime scene in slow motion. The domain is authors and books, familiar, simple, and absolutely dangerous at scale if you let JPA make decisions for you. By the end of this section you will be able to spot an N+1 problem before it ships. The author entity owns a one-to-many relationship with book. The fetch type is explicitly set to lazy on the books collection. Lazy is actually the JPA default for one-to-many, but writing it out loud makes the contract visible to every developer who reads this class. Book maps the many-to-one side back to author. The critical detail is that many-to-one defaults to eager in JPA, meaning Hibernate would join and load the author automatically on every book query. We override that to lazy here, which is the recommended production setting, and we will see exactly why that matters shortly. The repository is intentionally minimal. By extending JPA repository, we inherit a full suite of CRUD and query methods without writing a single line of SQL. This simplicity is one of Spring Data's greatest strengths, and it is also what makes N+1 so easy to introduce without noticing. This service method is clean, readable, and correctly expresses business intent. A code reviewer might not flag it at all. With 5 authors in a local database, it runs in milliseconds. But every call to author.getBooks triggers a separate select against the database, one per author, and that is the N+1 problem in its purest form. The pattern is straightforward once you see it drawn out. One query loads all authors, then the loop triggers one additional query for every single author in that result set. For 5 authors, that is 6 queries. For 10,000 authors, it is 10,001, each one a round trip that acquires a database connection, competes with other threads, and adds latency. Before you can fix a problem, you have to see it. These 3 properties tell Hibernate to print every SQL statement it executes, format it for readability, and log the bound parameter values. Turn this on in development, and you will immediately see how many queries your innocent-looking code is actually firing. The math is brutally linear. The problem does not reveal itself in development because local datasets are tiny. It ambushes you in production at the worst possible moment, during a traffic spike, when thousands of these queries arrive in bursts, saturate your connection pool, and drive response times through the floor. Recognizing this pattern early is the entire point of this section. We close this masterclass by tackling one of the most damaging and most misunderstood JPA performance problems, the N+1 query issue. We will debunk the eager myth, learn how to detect the problem in any codebase, and then work through every major solution in order of complexity. Switching a relationship to fetchType.eager does not eliminate N+1, it either hides it by firing the extra queries automatically, or it trades N+1 for a single enormous Cartesian product query. Worse, every call to find all or find by now loads associated data unconditionally, even when all you need is the parent's name. The correct rule is lazy by default, eager by choice, per query, not per mapping. Even when Hibernate does collapse N+1 into a single join, eager mapping can produce a result set with hundreds of thousands of rows for modest data volumes. The Cartesian product grows multiplicatively, and for large datasets this single query can be measurably slower than the N+1 it was meant to replace. Lazy is the safe default precisely because it gives you control. This is the thesis worth writing down. Lazy by default, eager by choice, per query, not per mapping. This is the guidance in the Hibernate documentation, and the position Vlad Mihalcea has argued extensively. Declaring eager on the mapping is a global override that removes your ability to ever skip that join, a cost you pay on every single query for the lifetime of the application. Detection comes before cure. In development, SQL logging is your quickest tool. Datasource proxy goes further by letting you write an integration test that asserts exactly one query fired, causing the build to fail if N+1 regresses. In production, APM tools reveal the N+1 fingerprint as the same query template repeated many times within one request trace, each with a different parameter value. Hibernate's built-in statistics surface the total number of SQL statements executed per session. When you see 847 queries logged for what should be a simple list endpoint, you know you have an N+1 problem, and you know exactly which request triggered it. This is a zero-dependency diagnostic that works in any Spring Boot application with a 2-line configuration change. With detection covered, we move into solutions. We will work through fetch strategies in order of complexity, starting with the most direct and most transparent option, the join fetch clause in JPQL. This is the tool you should reach for first. The @query annotation tells Spring Data JPA to use this JPQL directly, and Hibernate translates it into a single SQL join. Distinct is mandatory. Without it, the join produces one author row per book, and Hibernate maps those into duplicate author objects in your list. Join fetch produces an inner join, excluding authors, with no books. Left join fetch produces a left outer join and includes them. Choose based on your data contract. The join fetch path collapses what was N+1 round trips into a single database call. Hibernate receives authors and their books in one result set and hydrates all the object relationships without touching the database again. The N+1 path, by contrast, starts with one query and then generates an additional query for every author in the result. The cost scales linearly with your data volume. Let's recap the key takeaways from this masterclass. If this helped you, hit the like button, subscribe for a new deep dive masterclass every week, and forward this to a teammate who would find it useful. Drop your questions in the comments. I read every one. See you in the next one.